The current informational status regarding the potential acquisition of JF-17 Thunder Block 3 fighter aircraft by the Republic of Azerbaijan from the Islamic Republic of Pakistan is characterized by a state of pronounced ambiguity and conflicting reporting streams, creating a complex analytical challenge for observers attempting to determine the factual progress of this significant defense procurement initiative. This ambiguity stems fundamentally from a direct and unresolved contradiction between two distinct bodies of information, one being a long-established and widely disseminated narrative propagated through international defense media and analytical channels, and the other being a more recent, countervailing claim that asserts a foundation in direct communication with official entities involved in the program's execution. The first, and most publicly visible, narrative has been constructed over many months through a consistent flow of reports from a diverse array of sources, including specialized international defense publications, independent aerospace analysis firms with expertise in tracking military aircraft production and deployment, and various regional news agencies with focus on South Caucasian and South Asian security matters. These sources have collectively and repeatedly reported, often while citing unnamed officials within the respective defense establishments or through analysis of observable logistical movements, that the delivery process for the JF-17 aircraft has not only been formally agreed upon but has actively commenced. The specifics embedded within these reports frequently extend beyond a simple confirmation of the deal's existence, venturing into detailed assertions that an initial batch of aircraft has been physically transferred to Azerbaijani control. This includes claims specifying the exact number of aircraft in this purported initial delivery, the precise mix of airframes between single-seat primary combat variants and twin-seat operational conversion trainer versions, and even more granular accounts alleging the public unveiling or presentation of these specific aircraft at a major international defense exhibition held in Baku. The pervasive nature, repetitive frequency, and high level of detail presented across these numerous and ostensibly independent reporting sources have collectively forged a powerful and widely accepted consensus within the public and analytical defense community that the agreement has successfully transitioned from a contractual and diplomatic phase into the stage of tangible implementation, with physical assets reportedly present and being integrated within Azerbaijan. However, this established consensus has been directly and explicitly challenged by the emergence of a second, countervailing narrative. This opposing perspective derives its claimed authority from a process of direct inquiry and subsequent verification allegedly conducted with official parties who are purportedly involved in the management and execution of the program. This counterclaim states with unequivocal clarity that, despite the volume and specificity of the public media reporting, no physical delivery of any JF-17 Thunder Block 3 aircraft to the Republic of Azerbaijan has in fact taken place at this current juncture. It is critically important to contextualize this statement, as this verification simultaneously acknowledges and confirms several key aspects. It affirms the existence of an active, genuine, and procedurally advancing acquisition program. It validates the understanding that the deal is progressing as planned through its necessary administrative and logistical phases, and it reinforces the expectation that the physical delivery of the aircraft is anticipated to commence in the foreseeable future. The crucial distinction drawn by this source is the definitive line it places between the advanced, penultimate stages of a complex defense contract, encompassing final payments, crew training, and infrastructure preparation, and the definitive, tangible act of physically transferring the operational assets from the manufacturer or supplier to the recipient nation. According to this particular source of information, the process has not yet crossed this specific, critical operational threshold. This fundamental disagreement creates what can be termed a verification gap, a situation where two credible-seeming sources of information present mutually exclusive facts. The body of reports asserting delivery, while extensive and detailed, is ultimately grounded in methodologies reliant on circumstantial evidence, the analysis of visual material such as photographs and satellite imagery, and information from sources who, for professional or political reasons, remain unnamed. While these methods are standard and often yield accurate results in defense analysis, they do not carry the weight of official, on-the-record confirmation. Conversely, the counterclaim of non-delivery, while presenting itself as a direct communication from involved officials, also remains an unattributed statement within the public domain, lacking a specific, verifiable point of origin from a named government entity or spokesperson that can be independently corroborated. Consequently, the most accurate and neutral assessment that can be rendered at this time is that the program for Azerbaijan to acquire the JF-17 Thunder Block 3 is confirmed to be an active and progressing initiative, but the widely reported and previously accepted status of the aircraft having been physically delivered is now a matter of serious and formal dispute between the established defense media ecosystem and a claim of more recent, direct, and privileged official communication. The definitive resolution of this contradiction is contingent upon a formal, unambiguous, and on-the-record announcement from an authoritative source, such as the Ministry of Defense of the Republic of Azerbaijan or the Directorate of Public Relations of the Pakistan Air Force. In the absence of such a primary source statement, the situation remains in a state of informed uncertainty. Regarding the technical and operational characteristics of the aircraft at the center of this procurement, the JF-17 Thunder Block 3 represents the most technologically advanced iteration of the lightweight, single-engine, multi-role fighter aircraft developed through a joint venture between the Pakistan Aeronautical Complex (PAC) and China's Chengdu Aircraft Industry Group (CAC). Its design philosophy prioritizes providing a cost-effective yet highly capable combat platform, offering a modern alternative to more expensive Western-made fighters for nations seeking to modernize their air combat capabilities. The enhanced performance and combat effectiveness of the Block 3 variant are fundamentally driven by a comprehensive suite of new generation technologies integrated into its core systems. The centerpiece of its sensor suite is the installation of an active electronically scanned array (AESA) radar system, which represents a significant generational leap over the older mechanically scanned pulse Doppler radars found on previous variants and many contemporary aircraft of a similar class. An AESA radar comprises hundreds of individual transmit-receive modules, which allow it to electronically steer its radar beam almost instantaneously across different directions without physically moving an antenna. This provides several critical tactical advantages, including a greater detection and tracking range against both air and surface targets, a superior ability to track multiple targets simultaneously while continuing to scan for new threats, a much higher degree of resistance to enemy electronic jamming due to its frequency agility, and a lower probability of being detected by an adversary's radar warning receiver, making the aircraft stealthier in its emissions. The aircraft's overall avionics architecture has been completely overhauled and is now built around a modern, fully digital glass cockpit. This integrates several large-area, high-resolution color multifunction displays that provide the pilot with a consolidated, easily interpretable fusion of flight instrumentation, tactical situation data from the radar and other sensors, weapon management status, and threat information. This human-machine interface is supported by a significantly upgraded and more powerful mission computer, which acts as the central nervous system of the aircraft, processing vast amounts of data from all onboard systems at high speed to enable more complex weapon management, basic sensor fusion, and to reduce the pilot's workload during high-stress combat engagements. Pilot effectiveness and situational awareness are further enhanced by the integration of a modern helmet-mounted display and sighting system, HMDS. This system projects critical flight and targeting information directly onto the pilot's visor, allowing them to see this data without needing to look down at the cockpit instruments. More importantly, it allows for high off-boresight targeting, a capability that enables the pilot to designate and engage adversary aircraft simply by looking at them through the canopy, even if the target is at an extreme angle to the aircraft's own flight path. The pilot can then cue advanced missiles to lock onto the target without having to first maneuver the entire aircraft to point its nose at the enemy, a decisive advantage in a close-range dogfight. Significant improvements have also been made to the airframe itself. There is a greater utilization of composite materials in its construction, which serves to reduce the overall structural weight. This weight reduction translates directly into increased performance, such as better thrust-to-weight ratio and maneuverability, or allows for a greater payload of weapons and fuel to be carried. Furthermore, the airframe has been structurally reinforced and its systems optimized to grant it an extended operational service life, ensuring decades of usability. In terms of its combat role, the aircraft is meticulously designed as a true multi-role platform, capable of effectively performing a wide spectrum of missions. For air-to-air combat, it is capable of employing the latest generation of short-range infrared-guided missiles, which are characterized by extreme agility, high resistance to countermeasures, and the ability to lock onto targets at very wide angles. It is also equipped to deploy advanced beyond visual range air-to-air missiles (BVRAAMs). These sophisticated weapons, often utilizing active radar homing, can engage and destroy adversary aircraft at distances of several dozen kilometers, a critical capability for establishing air superiority and denying enemy air operations. For air-to-surface missions, the aircraft can deploy a diverse arsenal of precision-guided munitions. This includes laser-guided bombs, which are directed to their target by a laser designator, and satellite-guided bombs, which use signals from global navigation satellite systems to achieve accurate all-weather strikes against fixed coordinates. Furthermore, the platform is capable of carrying and launching air-launched cruise missiles, which are standoff weapons that allow the aircraft to engage heavily defended high-value targets, such as command centers or integrated air defense systems, from a safe distance outside the range of many enemy ground-based defenses. The synthesis of these advanced aerodynamic, avionic, and weapons system technologies creates a potent 4.5-generation combat aircraft, designed to provide a balanced and formidable capability for air defense, precision strike, and maritime operations, representing a substantial and transformative technological upgrade for any air force that introduces it into its operational inventory.